We're having a bowling fundraiser at the Trenton Torque-Nados. It's going to be at 10 Pins of Trenton on February 19th from 1 to 4 p.m. A $20 ticket will get you 2 slices of pizza, and then you can also get 2 hours of the 3 for bowling. Each student needs to sell 5 of these $20 tickets so that we can reach our goal of 100 tickets sold.
Chelsea was designing a button. This is Chelsea's design. And then I made locker posters.
Alright, so this week I was able to make 2 different button designs for our Torque-Nados, and also this YouTube thumbnail over here, which is now posted to YouTube already. I also made this over here with our Torque-Nados for our charged up theme font and theme for this year. And this design was based off of our electricity vibe that we're going for this year as well.
I'm Michael. I'm with the CAD team. Recently we've been working on 3D printers. We recently put a Sprite hot end, which is direct drive, and it's got a CL Touch which enables auto leveling, CR. We were working on printing TPE, which is what we originally got the Sprite direct drive for. It's a flexible filament that also has elastic properties. Currently, we just have PLA in there to test it real quick after doing some quick calibration. And we're also working on upgrading this printer. We have another straight hot end here that we're going to put on this, but currently we don't have the main board because Creality sent us a defective one, so we're getting a new one. And we're also planning on putting this touch screen on this printer right here. It's just having, we just need to figure out some problems with the firmware, which is what our CAD mentor is working on right now.
This week for CAD, we had a new member start working on Tinkercad and then upgrade to Fusion 360, which is our new software. We worked on upgrading our 3D printers with new components, which Michael went over. We worked with Build Team to print pieces for robot prototypes, including this, which is a design to CNC to go on the side of the robot. And we finished switching all CAD computers to Fusion 360 from SolidWorks.
Hello, I'm Jackson. I just very recently joined a team from our FTC team, which is so exciting. Basically, I've been working on making the tablets work and making the scouting system work and observing what we need to change for this season.
Colleen made 5 different designs of the t-shirt, and by the green checks that are on it, we have an obvious winner, so this will be our t-shirt for this year.
This is what I made as like a test driving course for this year's game. So I labeled all the little things that we have. So this would be our robot, and to test the people who are testing for drive, you would need to test their agility first to see how they handle swerve, and then it's a test of if they can get back quickly and how quickly they can drop off their cargo from grabbing it from the human player or the cargo that's already there.
What I've been working on this week is further proving the telescoping pivot arm. Since then, Kaiser has come up with a calculator to determine the different distances, the different stages, where it needs to be mounted on the robot. So I've been working through that, and I've eventually brought it down to 3 options. Either a 1-stage mounted low and at the rear, a 1-stage mounted high up and at the rear on a slide, or a 2-stage mounted up high and at the rear. And right now we're working through which of the 3 we think is best. We're also going through pros and cons of elevator. Those are our 2 final delivery system options that we're deciding between right now.
The claw that they made, we programmed so it is automatic on a sensor. So when it is, like when there is one of the game pieces in between, it will automatically grab it, but we hold the A button on our controller to let it go, and otherwise, if you click it, well, there's still something in between, it will automatically grab it either way. So, you know, it automatically grabs, but you have to unlock it automatically, so it won't drop, so you have to press the button.
So on the robot, we use swerve so that it can drive in any direction, and we have a button to toggle between field-centric and auto-centric.
The part that me and Leo worked on was the claw design here. It's 2 pneumatic pistons that have 2x2 on them that are both on a rail that when this sensor detects that there's something in front of it, it will close the arms. And we have these 2, it's closed right now, but there are 2 silicone 3D printed reels with silicone on the inside that move around when it's not closed. These move around on over here with little ball joints, so if the cone was tipped over, it would be able to pick it up.
They spin, so when the cone is down, if these were on moving arms, it would move this up and the cone would self-right itself to the correct position, as long as we don't grab it below like this line, because here, if you grab it, it'll turn like this, but anywhere above that, as long as it can still squeeze it, it'll self-right to this way.
So we chose to do an elevator just to experiment with it to see if it'll work for being able to raise it and lower, like what Jack was talking about, an arm to be able to score easier, to make it picking up and moving pieces easier.
So I decided to take on the wheel design, and what we did is we used wood and angled it, and then we realized that it was kind of hard to do it, and we didn't want it to be super long or super wide, so we took the measurements of the cube, about 8.5 inches, and we put this down to where it's 8, so that this can just go, and it just goes right out. And then we had a spot right here. We noticed that the cone would just kind of come out like that, and it wouldn't really stay in, so we created a space where it can stay in and it doesn't fall out. And
Well, ignore that part.
but yeah, I thought that if we used wheels, then it would hold onto it. It wouldn't move like it is here, and it would hold onto the cube and cone really securely, and it won't fall out. And my prototype, I would shake it around and the cube would not fall out. I think I tested it on this one and it still does not fall out. And then the cone was really iffy on the first one, but I'm pretty sure that on this one it's pretty much stay in. So